Okay, here we go. All right, so I do have a quiz, or not a quiz, a 2 quiz grade assignment that you're supposed to turn in today, which was all those problems, right? But I do want to answer maybe any questions that you might have had on that. So Miguel, go ahead. Number 19. So we are working off of 434, number 19. Yes. Okay. 19. So number 19, x to the 8th y squared plus 8 x to the 5th y squared. This is the one, right, Miguel? It's y squared twice, yes. Is that, yes? Okay, so we start going through those steps, and everyone has that handout that I gave you, right? That has the general factoring strategies. So the first step, anyone else need it? I brought a couple of copies today. Factor out the GCF. So do we have a GCF? How many x's do we have that we can factor out here? 5? Now, I've been saying that for the entire semester. How many x's do we have? And we say 5. I'm kind of playing very loose with those words because actually when you say 5 x's, you really mean 5 times x, all right? We have x multiplied 5 times, so x to the 5th is what we have in common. So just, you know, it's just language, but we all understand what we mean, right? Pull out 5 x's means pull out x to the 5th. Okay, now how many y's? Y squared, so we'll pull out y squared. All right, and now, yeah, well, that's the thing. Don't mix it up. It's y squared, not 2y. All right, anything else? No? Okay. So we have to figure out, what do you multiply x to the 5th by to get x to the 8th? X cubed. And then we need y squared to become y squared, but we already have it, right? So we don't need anything there. So we're done. X cubed. Now let's look at the other one. We need an 8, don't we? So we put plus 8. We need an x to the 5th. Well, we have x to the 5th. We need a y squared. We have a y squared. So just x cubed plus 8. That's it. Not cancel, but when you multiply that through to the 8, you will get that up there. So we don't need more, correct? So at this point, you look at everything. You look at what's in the parentheses especially, and you see if what's in the parentheses will factor. It's 2 terms, right? When you have 2 terms, you look at those formulas. Is it a difference of cubes, sum of cubes, difference of squares, sum of squares? Yeah. Are you raising your hand? Oh. Okay. So what is inside there? X cubed plus 8. That's a sum of cubes, right? I'm doing this on the side. That's something cubed plus something cubed. And x cubed comes from x being cubed. 8 comes from 2 being cubed. So in our formula, x is a, and 2 is our b. And the formula says it's a plus b times a squared minus ab plus b squared, like that, right? So that's what that'll become over there. So I'm going to go back over here. I have x to the 5th, y squared. I have set of parentheses for a binomial, set of parentheses for a trinomial. The binomial is a plus b, so x plus 2. And then a squared is x squared minus a times b, which is the x times 2 or 2 times x, right? We'll write 2x. And finally, plus 4. That comes from the b, which is 2 being squared. And then what did we say about this trinomial out here? They won't factor, right? Okay, so I don't have to worry about that. And then x plus 2 is 2 terms, but it doesn't look like a sum of cubes or a difference of cubes or sum of squares or anything like that. So it's prime, it won't factor. So this is it. This is our answer. Okay. Yes? 39. It's prime. But you got an answer? Okay. Let's see. 12x squared plus 6x minus 35. You did copy the problem down correctly? Okay. Okay, so what did you do here? What did you do to start this? That's the problem. This is not divisible by 6. If it was 36, then yes, right? You did that also? Okay. Yeah. Because if that was a 36, this thing would factor a little bit. Yeah. 47. Okay, on this one though, let's just show that it was prime. You would do this, right? You would multiply 12 times negative 35, which is negative 420. Hey, none of that in here. Did y'all hear about Easter's on 420? Did you hear about that? I got it on my Facebook. Easter's on 420, and it was a picture of a bunny with a joint hanging out of its mouth. I tell you, people. All right. So you mess with those numbers and no go? Yeah, so you go all the way through your list of numbers and nothing works, and therefore it's prime. Yeah. Now on a test or something, I won't give you a number this crazy where you have to spend like 10, 15 minutes trying to show it's prime. It'll be a small number. Your list will have 2 or 3 or 4 little things in there, and you're done. Okay? Okay, so what was the other one? 47. (108b squared) minus 36b plus 3. All right. I'm seeing GCF here. I'm thinking that 3 goes into all of these. Does it? Yes. So 3 goes into 108 how many times? 36. So I have 36b squared minus 12b plus 1, right? Good. So that was a GCF coming out first. And then what's inside the parentheses is a trinomial. So I'm going to try my little AC method thing here. I multiply 36 times 1, get 36. And then I get negative 12. Did anyone get those numbers? What are they? 6 and negative 7? No. Oh, negative 6 and negative 6. Okay, good. Is that right? Everyone see that? So what method did we all kind of conform to? Did we have anything we agreed on? The grouping one or the super fast one? The grouping one? Let's do the grouping one. The grouping one, you take the two ends, right? 36b squared. You take the plus 1. In the middle, you put what? Negative 6b, negative 6b again. Now, if you like that other method, then stick with it, right? That's what I've said, but I'll do this one. Now we do our grouping, so we split it right after the second term. What comes out of the first one? The first two terms. 6b, right? What's left? 6b minus 1. Then you have to, okay, well, remember, our goal is to try and match this, right? We need to match that over here. So I need to just write it down. Bless you. 6b minus 1, right? And when I look up here, I don't have 6b minus 1. I have negative 6b plus 1. So to turn 6b into negative 6b, I need a what? Negative 1. You see that? Okay, so I put a negative 1 here. And if you check it, the negative 1 will give you the negative 6b. The negative 1 and negative 1 will give you the positive 1. And remember, I just have these parentheses to keep track of everything. Big parentheses here in here to keep my 3 outside by itself. But now I've got my grouping working out in there. So this equals 3, and then I should have 2 sets of parentheses here. Right? What is it? 6b minus 1, and then you put the things that are in front. Hey, isn't that the same thing? 6b minus 1 again? So that I would accept as an answer, but remember I said that I would be happy if I saw this. Did I tell you all that? Yes, I'd smile, right? $35, yeah. Do y'all see that, though? Any questions? All right, this will be my last one, 35. All right. X to the 4th plus 5x squared minus 36. All right, now this is a special type of trinomial, and today in class I'm actually going to look at a different special type of trinomial that we need to be able to recognize when we see it. For this trinomial, notice that, well, we have 3 terms, right? We have no GCF, so we would normally attempt to do our AC method, wouldn't we? Because there's 3 terms. What we have to be careful with is our grouping part. So just pay attention for a second. Let's see what happens. I was expecting to have questions on this one. We take the number in front, which is 1. We multiply it times the back. It's negative 36. Okay, and then we take the number in the middle, which is 5. You work with those numbers, you come up with what? 9 and negative 4. Agreed? Okay, now we do our grouping part. So we bring the 2 ends down, right? X to the 4th, and then on the other end, minus 36. And then think about this for a second. What is it that we need to get in the middle? We need a what? We'll use the plus 9 and the minus 4, but those need to come together to become a 5x squared, right? Not a 5x, a 5x squared. Do you all see that? In the past problems, it's always been just like an x, and this was x squared. So when I use those 2 numbers, I need to put plus 9x squared minus 4x squared. Yes? It has to be x, you put x squared plus 9x. I mean, yes, that won't be right. Right, well, I have to see what you're talking about. Let me see. It's hard for me to, you put where? This right here is correct. The next line, this next line, you're saying right here? Yes, sir. Okay, let me show you. There's something missing. When you pulled out an x squared, this should not be an x right there. You're close. All right, any questions on that part? Okay, I'm going to split this because I have 4 terms. What can I pull out of the first 2? An x squared, right? I'm left with x squared, hold on, plus 9. Just 9. Now think about this. If we distribute this through, x squared times x squared gives us x to the 4th. X squared times 9 just gives us 9x squared. If you had a 9x there, it would have given you an x cubed, right? Got it? Okay. Now, we need to match that with the other grouping, right? We need to match it. So I need an x squared plus 9 in here. And that means I need to turn an x squared into negative 4x squared. So multiply it by what? Negative 4. And then just check, does negative 4 times positive 9 give you negative 36? Negative 36, yes. Yes.
On the top, when you say that you instead of putting like 9x or whatever it is, 9x squared, put that, what if it's cubed?
Yes, it's whatever's there. Look, what you're trying to do is take that, you're trying to take positive 5x squared, right? You're trying to create this using these 2 numbers. So what you do is you forget the x squared there for a second. How do you create a 5, 9, and negative 4? But then you need that, whatever's there, you need it. So it'll be 9x squared and then minus 4x squared. Had this been x cubed, you would have put 9x cubed minus 4x cubed. Had it been AB, you put 9AB minus 4AB, which you're about to see in the next example. Okay? All right. Next. They match, right? Since they match, I put whatever matches out front. And then the other set of parentheses gets the two things in front, which are the x squared minus 4. We are not done. That's right. This right here is a sum of squares. Can you factor sum of squares? No, not a sum. Difference you can. Difference of squares, x squared minus 4. And I think, I'm hoping, we'll take a vote. Okay, let's just see. No one be shy. How many of you are to the point now where you can look at this and just know it's x plus 2 times x minus 2? About half? Okay. All right, so you want to get to the point, because this is one of those ones that, I mean, that's like a very basic difference of squares, because it's got x squared, and it's got minus, and then it's got a perfect square next to it. And there's only a few that are like this that you should recognize, like x squared minus 1, x squared minus 9, x squared minus 16, x squared minus 25. All of those are those difference of squares that are very common in math. So without working, I'm going to go x plus 2, x minus 2. And now each of these cannot be factored, right, any further. So we are done. Box it up. Now, anybody use the other method, the short? Anyone use the short? No, you use the grouping, though. Use grouping, right? Yeah. I'm talking about that one where you put the number out front and put it underneath. Anyone do that?
I did, but when I went to the lab,
they slapped your hand? Yeah, okay.
You know what happened when you go to the lab? It's like you go one mindset from here, and they brought me over there, and it's like they shake your brain, and they let you go.
Yeah.
You are like, oh my God. So
I know.
the best thing is just watch. I watched the videos the whole weekend. I was like, oh my
Let
God.
me give you my slight opinion, and I'm going to pause the video. All right, we are going to move on, but I would like to at least collect what you have. All right. Whatever I sent home, the 2 quiz grades. Yep. It was about half of that assignment. Mm-hmm. I did? So you didn't know? You did get the homework, but the quiz wasn't. Okay. All right. You know what it is? No, I don't. Okay, I'll tell you afterward. Yes.
I'm with the access office.
Yes.
And they had given yesterday, and they gave me some papers for somebody to help me take notes.
Yeah, yeah. Okay, great. Awesome. Thank you for doing it. I'll give you bonus points for that. Yeah. You did like what? No. No, it was a pretty big assignment. Yeah. Anyone else? Yes. Okay, go ahead. Let me go back to what the assignment was. That way everyone knows. Oh, there was this, right? Okay, that's what you did? That's what the quiz is. This is to be turned in for 2 quiz grades. So if you did that completely, you're good. Yeah. Okay? Anybody else? Why do you think I made you do that for 2 quiz grades? Because I love punishing you. No, because factoring, I've been telling you, factoring is the most important thing that we leave this class with, all right? So I have to force you to do the homework, to know that you did it, all right? It is. It is. But eventually it starts to become less painful. The more you do, the less painful it becomes. You've heard the term everything is relative. I mean, that's Einstein's theory of relativity. Everything is relative, right? Like, one idea of relativity would be, am I far from SeaWorld right now? No? Am I far from Austin? Am I far from the sun? Okay, compared to the sun, am I far from Austin? No, I'm real close to Austin compared to the sun. It's relative, right? It's all relative. So when we are in a class like this, math works like that a lot. In a math class like this, everyone's suffering through factoring, right? And then as you move on to the next math classes and you start progressing, you realize that the suffering you were doing before, you wish you had that back. Like you were like, I thought that was the worst it could be. That was the worst pain. But now I wish I could have that, because that's the easy stuff now. That's the way math kind of works. It builds on itself in that way. But eventually everything becomes okay. You just have to keep working at it. So it's the military, right? They yeah. Yeah. All right, I want to take a look at number 13 because nobody asked me about 13. And I really was thinking that's exactly what I would be asked this morning. Okay, for this problem, this is again one of those special, what do you mean?
Number 13 is in here.
What do you want to do with it?
I want to just check the answer.
Oh, okay. Okay. So let's look first for GCF. Do you have GCF here? No. Okay. Do you have, let's see, well, not do you have. We have a trinomial, right? 3 terms. So since we have 3 terms, we will try an AC method. Now, notice, though, that this is the first time we've ever had this. Not only do we have a variable squared over here, kind of like x squared plus, like if we had 2x minus 15, right? This is something we've kind of seen before. We had x squared, and then we had like an x here and just a number. This has not only an a squared, it has an a and a b, and over here a b squared. This is a very special format that we need to kind of recognize. We have squared variables on the ends, and then both variables not squared in the middle. Do you see that? That is going to factor correctly using AC method, but we have to pay attention when we do the grouping. So let's do our cross thing. What are the numbers here? Negative 15 and 2. Okay, we come up with some numbers that multiply to be negative 15, add up to be 2, which would be 5 and negative 3. And now let's try this grouping. We have a squared, over here minus 15b squared, right? And then we can rewrite this middle term using the 5 and the negative 3. So plus 5, what? AB. Because remember, we're trying to get a negative 2AB, right, Miguel? Okay, so we use 5AB there, and then the minus 3, and then AB again. Okay? See how that works? Every time, that's what you would do. You try and match up that middle one here. Then split it, and proceed with your grouping off those two. Okay? Is that what you had? Yes? Okay, so pull out an A, right? A plus 5B, and then on the other one, we need it to match. So what would we pull out of the second one if we want this to match? Negative 3. Hold on, negative 3, B. B. Did y'all see that B is in there also? Each one of these has a B. So you get A plus 5B, and then the other parentheses, A minus 3B. And that's it. Okay? All right. Turn it in. I can't sit here and let you change it. That's not fair to everyone else, right? I mean, I trust that you did, but I'm just, you know, it's, oh wait, is this in order or? Oh, your name's on it. Okay, good. No, it's okay. I'll keep it in order. Whoa! That's happened before. Remember, when I was a student in graduate school, I had a very important 9-page paper that I was walking, and the wind gust blew it, and it went off this like 3rd floor, and I was like, just in my mind, it was all slow motion, you know, and I just like looked at every piece of paper and where it went, and I ran down 3 floors, and I was able to find every piece of paper. It was, yeah, it was pretty funny. Okay, so that pretty much does it for what we were doing last class. I only had you go up through what, 47? Okay, so let's try and continue to go through these things, and then we'll move into the next section. All right, so I'm going to give you more homework out of here tonight, this section. Yeah, so not much is going to change, though. It's all going to be pretty much the same ideas. There's nothing really new. Well, because I want you to succeed, so I'm going to make you suffer, and then you succeed. Well, we're planning on having a test. It was supposed to be on this Thursday. We're going to push it to Tuesday, right? Yeah. Yeah. We will review maybe next class, and I'll give you the review for over the weekend. All right, so GCF. Do we have a GCF? No? Okay, 3 terms. Okay, let's try AC method. I think that this grouping method is really, really the way to go, isn't it? I mean, this cross, the grouping. What's the number we're going to be working with? Negative 72 and 34? That's the way it goes sometimes. So let me look at all the factors of 72 here. 1 and 72, 2 and 30, 2 and 36, right? If I can just get the signs right. Negative 2, positive 36. That works, doesn't it? So with the grouping technique, I take the first term and the last term, rewrite those, 9x squared, and then over here, minus 8y squared. In the middle, I'll use the 2 numbers. Miguel, do you want to tell us what it will be in the middle?
Minus 2x.
Good. And then, there you go. That's it. Okay? So we're just matching up what we needed in the middle, right? Here and here. And then you split it and you do your grouping on this. Take your time. What comes out of the first 2 terms? Just x, right? We are left with inside 9x minus 2y. We need to try and match that on the other one, 9x minus 2y. So how do you turn a 9x into a 36xy? You need a 4, right? And a y. Plus 4, and then you also need a y. You see that?
Yes.
Okay. And you could double check it, do the 4y through the last one here. 4y times negative 2y is negative 8y squared. Now write them out. 9x minus 2y, that's what matched. And then in the other parentheses, x plus 4y. There you go. All right. These don't factor, right? No difference of squares, so we are done. think we'll do one more example, and then we're going to move to another section. Do I need to leave that up, or we're good? Okay, how about this one? Y squared times, in parentheses, x plus 2 minus x plus 2. Pardon? This looks different than a lot of things I've put up here so far, doesn't it? It looks what? Yeah, it looks kind of like an answer, doesn't it? Doesn't it look like kind of like this problem right here in the grouping, like we have the same thing in parentheses, same thing in parentheses, and then we just pulled that thing out, right? That's exactly what this problem is. It's just trying to get you to see it in the beginning and not have to work. Like if you work through all the grouping, you know what you're supposed to do at this step, right? Pull that thing out. But if this is the way the problem is presented to you, it might confuse you that you're already at that step. They want you to kind of be tricked by the fact that these are the same, so we just pulled that out. So there's not a whole lot of work on this problem. Just pull that out. What do we have out front here? X plus 2, right? And then in the other set of parentheses, y squared minus 1, right? Very important that you see that that was a 1 in front there. Do you all see that? Are we done? No. This is the difference of squares. And y squared minus 1 turns into what? Y plus 1 times y minus 1. Again, that difference of squares here, turning into those two, is one of those things that you just want to start to get to the point where you recognize it, okay? Now we are completely factored. All right, this is what I'd like for you to do for homework. Page 435. We stopped at what, 47? 435. Well, you actually started at 434, but you're going to pick up, I don't want to really kill you here, but let's go ahead and do it anyway. No. 51 through 89. Now, hold on. Every other even, or odd, sorry. That means you'll do 51. These are the odds, right? You will skip every other. So you'll do 51, skip 53, do 55, skip 57, do 59, do every other odd. Okay? All the way till you get to 89. Understand? Now, if you are wanting to practice and you're wanting to get better at this, do all the odds, okay? And if you want to get even better, go do all the evens, you know? That's what we tell our calculus students, you know? We're just like, here are the problems you should do, but you should actually try and do all of them because it benefits you. Yes, 435. The other homework started on 434 because it started with number 11, but we're on the other page now. All right, let's move to the last topic that will be on our test, and that's the whole reason why we do this. All right. The whole reason why factoring is so important to us. It is called the zero, this is 6.5, or 6.6. The zero factor property. Here's what the zero factor property says. This is a very, very important property in mathematics. It says this: if A times B turns out to be equal to 0. Okay, this is an equation. You see the equation? If you take two numbers or two things, it doesn't even matter if they're numbers. If you take two things, an A, and you multiply it times a B, and that answer turns out to be a 0, then you can guarantee one of two things has to be true. What do you think? Then one of those has to be 0. Then A must equal 0, or B must equal 0. One of them must be 0. The only way two things can multiply to be 0 is if one of them is. That's called the zero factor property. Now you can extend this even further. If A times B times C equals 0, so what if you have three things that multiply to be 0? Then one of them has to be 0. Okay? Then A must be equal to 0, or B must be equal to 0, or C must be equal to 0. And you can imagine that you can extend this property to A, B, C, D, right? Now, what we've been doing in this class so far is we've been factoring, right? We've been taking expressions and we've been turning them into something times something times something, right? Each of those things in parentheses were what we call factors. So anytime that we can get an expression, we factor it and set it equal to 0, what we'll be able to do is look at each one of them equal to 0 separately. All right, now I'm going to do this in red. Careful. If I say A times B equals 2, does this mean that A has to be 2 or B has to be 2? What do you think? If two things multiply to be 2, do one of them have to be 2? Can somebody give me an example of two things that multiply to be 2 where neither one of them is 2? Well, 2 and 1, one of them is 2, right? What I mean is, if two numbers multiply to be 2, then can you say that the A has to be 2 or the B has to be 2? That one of them has to be 2. One of them? Now, I just told you to swallow that pill a second ago, that if two numbers multiply to be 0, then one of them has to be 0, right? Does it work for any number, though? If two numbers multiply to be a number other than 0, does that mean one of them has to be 0? Let me show you. What if A is 4 and B is 1/2? What would happen if you take 4 and you multiply it times 1/2? What's half of 4? 2. So that would follow 4 times 1/2 is 2, isn't it? Is 4 2? Is 1/2 2? No. So I just gave you an example of two numbers that multiply to be 2 where neither one of them were 2. This property does not hold, okay, if you have a number over here other than 0, which is why they call it the zero factor property. This only works for 0. See, I don't care how long you sit there. You pick a number, I guarantee you, if you take two numbers and multiply them, the only way you're ever going to get 0 is if one of them is 0. Okay, it's the only way it's ever going to happen. Just think about it. Pick anything for A. I don't care. Give me something for A. Okay, 0.67 something, right? Now I have to figure out a B to multiply that by to create 0. The only thing that's going to make that go away is 0, right? So then you say, well, okay, what if A is 0? How are you going to make it 0? Well, it is 0, so then I don't have to worry about it, right? So the zero factor property, extremely important, all right? Extremely important. How will we use it? Solve this equation. Hold on. Whoa. All right, now I want you to see something has changed today so far. I am giving you the instruction to solve, not factor, right? I am giving you an equation. We have not had an equation for weeks, have we? So we're finally looking at a problem, and what we want to do is find a solution to it. Solution means, can you please tell me right now what I need to plug in for x to make this equation true, right? Here's an example of another equation in case we've forgotten what an equation looks like or what it means. If I give you this equation, x plus 4 equals 0, right? I'm saying, what do I plug in for x to make that true? Negative 4, right? Negative 4. So negative 4 plus 4 is 0, so that's the answer. The solution here is x equals negative 4. Yes? Okay, so that's what we mean by solutions to equations. This equation, though, is complicated. It's what we call a quadratic equation because you have x squared. But do you recognize the left side? What's the left side? It's a trinomial, isn't it? The right side is equal to 0. So maybe I can factor the left side of this equation. We can, right? Let's do that work. I would come in here with my cross. What numbers go in there? So 1 and negative 12, and then the number in the middle, negative 4. So we come up with two numbers that multiply to be negative 12, add up to be negative 4. So what? 2 and negative 6. Now we do some grouping. So watch what happens here. I bring my x squared down. I bring my right side down, which is negative 12. In the middle, what happens? Plus 2x minus 6x. Now I'm missing something very important here. Equals 0, right? Keep the equation the whole time. Equals 0. Any questions? The only difference so far is that I have an equal 0 in the problem and I'm bringing it down with me the whole time. Okay, now I split this. I do my GCF on the first two terms, which is x leaves me with x plus 2. I need to match that on the other one. So what goes out in front of this? You need it to be negative 6x, so negative 6. It's all right, right? Because you're looking at the x, not the 2. So negative 6 times x gives me negative 6x. Negative 6 times positive 2 gives me negative 12. What do I still have next to that? Equals 0. And then the grouping gives me x plus 2, right? Times, in parentheses, x minus 6 equals 0. Do you all see that? Now, what we have here is exactly the 0 factor property. We have an a times a b equals a 0. Do you see the 0 factor property there? I'm saying that something times something equals 0. Earlier in the problem, at the very beginning, I did not have something times something equals 0, did I? I had something minus something equals 0, but not multiplication, right? You see there weren't factors. They were terms. But I have turned it into a problem of something times, right there, something. Now, according to the 0 factor property, if two things multiply to be 0, right? If a times b equals 0, then that means the first one is 0 or the second one is 0. So what I'm going to do now is, using the 0 factor property, I'm going to split this off into two separate problems. It's now going to become the x plus 2 must equal 0 or the x minus 6 must equal 0. Does that make sense, what I just did? That's applying the 0 factor property. Each one of these are what we call linear equations. So you have to go back into your bag of tricks on how to solve linear equations. First thing we do to solve a linear equation, we try and isolate the variable, okay? How do we get that x by itself over here? We subtract 2 on both sides of the equation. That ring a bell? When you subtract 2 on the left, it goes away. I'm left with x. On the right side, 0 take away 2 is negative 2. And that is a solution to the equation. On this one, what do I have to do to get x by itself? Add 6 to both sides? Because it's a negative 6, right? I want to do the opposite, so I add 6 instead of subtracting. I get x is 6, positive 6. Understand? Questions? Well, what's new in this problem? I mean, really the only thing that's new is this part that equals 0, and then once we got here, now what we have to do is take each of those and set those equal to 0, and then just solve them. Right? Well, yes, this is our final answer, but I want to show you that it actually works. The original problem was x squared minus 4x minus 12 equals 0, right? Let me show you that negative 2 works, okay? Because no one in this class is, well, I don't think anyone in this class, when I put this problem up in the very beginning, I don't think anyone looked at that and went, ah, sure, negative 2 and 6, that's what works, right? There has to be a method. There has to be a way of getting to those answers. But let me show you that negative 2 and 6 will, well, I'll just show you negative 2 works. I won't show you 6. Negative 2, I plug negative 2 in, so that means I have to square it. Minus 4 times negative 2, then minus 12. Does that equal 0? Well, what's negative 2 squared? 4. And then what's negative 4 times negative 2? Positive 8. And then I have minus 12, right? Does that equal 0? Sure. 4 plus 8 is 12. 12 minus 12 is 0, so that works. So that is a solution to that equation. With me? I want to show you something. Not to scare you, but I have students that always ask me, like, you know, why are we doing this? This is an exam for one of my calculus classes. I want to show you, let's see, which one was it? No. Ah, here we go. All right. So in this problem that I gave this class, let me see if I can remember what it is. I don't think the problem is that important. This is a physical problem. Basically think about it as like a satellite moving through space, okay? Moving around out in space. And here's the Earth, and you want to know when that satellite is closest to the Earth. Like when the distance between that satellite and the Earth is the closest. This is the math that would be required to solve that problem. But I want you to just take a look right here. Just right there. Z minus lambda z. Now don't worry with the fact I'm using z's and lambdas. Lambda is just a variable like x and y. But look what happens here. What do we have to do from here to here? What happens from here, right here to here? What do these both have in common? A z. So the z gets factored out, right? And then I have a times b equals what? 0, right? So this is the 0 factor property. So I take that z and I set it equal to 0. I take the other one, I set it equal to 0. Well, when I set this one equal to 0, right, when I take this one right here, 1 minus lambda equals 0, all I do is move the lambda to the other side by adding it. So I get 1 equals lambda. So that's where this comes from. But the point of me showing you this is that factoring, right, is just one tiny, tiny step in a bigger problem. And that's the way math works. It builds upon itself. Yes? Up here? That's a function of 3 variables. Yes. This is actually the distance between, this is the function that represents the distance between a point in 3-dimensional space and the point 1, 2, 0. So that's what it is. I think I have a picture that goes with the problem. I might not. Yeah, there it is. Okay, so there's the picture of what this problem was actually asking. There is a point, and then this is like some surface, and we're trying to find on this surface what point is closest to that point. It turns out there were 2 answers. Okay, but see, the factoring, though, is just built into almost all the math that anyone would do past this. It's just little intermediate steps used all over the place to solve things. Exam, let me see here. I'm still in the wrong class. Shall we do another one of these? All right, Day 18. Okay, let's start with something else. Let's go 2x squared minus, or equals 14x. All right, as this sits, is it an equation? Yes. Okay, so this is very different again. We have to recognize now we have equations. And I should probably tell you somewhere up here, I want you to solve this. The only thing we have right now is the 0 factor property. That's all we've got, okay? If we can get this to look like A times B equals 0, then we can do what? Set the A equal to 0 and the B equal to 0 separately, can't we? We do this, or we do this. But right now I don't even have equals 0, do I? So how do you think I can get equals 0? Okay, yes, in some way, change the signs. With equations, aren't we allowed to always move things from one side to the other? Right? Yeah, you could go everything to one side or everything to the other side. If I move everything, let's say, to the left side of this equation, what would be left on the right side? Nothing, right? And nothing is 0, isn't it? The only way to get nothing on the right side is to take away that 14x. So I'm going to subtract 14x on both sides. Now I have to do it on both sides, right? On the right side, I get 0, which is good. On the left side, can you do 2x squared minus 14x? Can you combine those together in any way? You mean just side by side? Okay, but I mean it doesn't turn into like negative 12x or something like that, right? We cannot combine them in the sense that they are not like terms. Because one of them is x squared, the other one is x. Like terms have the same variable raised to the same power. So there's no crazy math that happens here, you know what I'm saying? Like that doesn't turn into negative 12x. Right? You don't do 2 minus 14, get negative 12, and then, oh, x squared, take away an x. Oh, I've only got 1x left. That's not what happens, right? Now, I'm getting closer to the 0 factor property. I just need to turn these two things that are right now being subtracted, I need to turn it into multiplication. Well, that's called factoring, right? Factoring turns expressions into multiplied expressions. So look at these. I have 2 terms, right? But what's the first thing we always look at? GCF, right? I do have a GCF in those 2 terms. What is it? 2x. What is left? X minus 7 equals 0. Now look at what's left here. I can't do anything to factor this. The x minus 7, can I do anything to this though? Is it like a difference of squares or anything like that? No. So, I mean, just ignore that for now. I mean, if this was its own problem and we said factor, we'd be done, wouldn't we? Okay, but we're not because we have the equal 0. So now I need to use this property. What's the thing that's kind of like my A here? The 2x is like my a, and then times the x minus 7 is like the b, and then the equals 0. So that tells me that I can take the 2x, right, set it equal to 0, or take the x minus 7 and set it equal to 0. Yes? Now, look at the first one, 2x equals 0. Let's not overcomplicate this. What is the operation between the 2 and the x here? Multiplication. You want x by itself. How do you undo multiplication? You divide. Divide both sides by 2, right? When you divide both sides by 2, on the left side, 2 divided by 2 is 1, so you get just x. What is 0 divided by 2? 0, right? Okay, the other one. You have subtraction here, right? So that means I want to get the x by itself. To undo that subtraction, I will add 7 to both sides. On the left side, it goes away. I'm left with x. On the right side, 7. So the solutions to this equation are 0 and 7. To use the zero factor property, you must get it to look like a times b equals 0. You have to get it there, all right? We're going to do a one question. Oh, man, I don't think I have enough time for a one question quiz. What do you think? You think you can pull off one question quiz in 7 minutes? Why don't you try? Take out a piece of paper. See if you can do this. I'll try and make it as nice as I possibly can. Now, I want you to work alone, but you can use your notes. All right? I want you to see if you can solve this in the next 7 minutes and turn it in. But do your own, okay? I did one just like this a second ago, so look in your notes.